Okay, so 4.1, Unit 4, Chapter 4, whatever you want to call it. So, and this is a topic I'm not sure that you touched on in Algebra 1, so I think this is going to be kind of new to you guys. We've been talking about exponential functions, right? Exponential functions have the variable where? Up in the
Exponent?
Up in the exponent, right? And as you probably are aware, every function in math has a function that undoes it, has an inverse function, right? Like what undoes addition?
Subtraction.
And what undoes multiplication?
Division.
And what undoes taking the square root?
Square.
Squaring, right? And vice, and they undo each other. So an exponential function also has a function that undoes it, okay? That's called logarithms, okay? So I think it's probably best if we start out where I give you a quick note to establish a baseline here. So let's go to our notes page real quick. All right, so we know that an exponential function right, has its variable in the exponent. We just talked about that. Variable in the exponent. Okay? So like if we have y equals 3 to the x, right? That 3 here, right, is called the base of it. Right? Or you might have y equals 5 to the x plus 3, right? We've seen this before. And of course, the 5 here is the base of the exponential function. Okay? So if that's an exponential function, up till now, you don't really have a way to solve for the variable up there unless you have common bases, right? Unless you can write, you know, like powers both sides of the equation, powers of 2, right? That kind of thing. But if you can't write them as the same base, then we need to use something called logarithms to solve for what's up in the exponent, okay? So logarithmic function. It is the inverse of an exponential function. Inverse of exponential function. Right? So it undoes it. Okay? And it will look something like this. Y equals, we abbreviate logarithm as log base b. See that it's a little subscript b, right? When you write it, make sure that's a subscript. That b can be a 10 or a 2, or sometimes Euler's number e, right? Of a, some other number. So that's what it'll look like. And if there's nothing in the subscript down there where that b is, you can assume that it's a 10, okay? That's the most common logarithm. So these functions undo each other, all right? The exponential and logarithmic. These functions undo each other. And by undo, you might just say solve each other. If, right? They will undo each other if the bases are the same, okay? If bases are the same. Okay? And of course the b here, right? That's the base of the log function, right? And if it's the same as the base of the exponential function, they will undo each other. So if we have this, here's one way to look at this logarithmic statement right here. So if the log of base b, log base b of a equals y, here's what this tells you, okay? So this is pretty important here. if the log of base b equals y, then we can say b to the y power equals a. Then b to the y power equals a, right, in that format. Everybody catch how I drew the arrows there? Might help you a little bit. So b here is the base in this log function. It's also the base in this exponential function, right? And we can say that b to the y power equals a. So this will be an important thing to know. It's one characteristic of logarithms. We just abbreviate it log. Okay? All right. Does everybody have this written down? We can go back to the first page now. Okay. So as you know, right, if two functions are inverses of each other and you graph them, who remembers when you graph them that they would be a reflection in what line?
Y equals X.
Y equals X. So let's look at exercise 1 here. So exercise 1 here, we have this exponential function, right? F of x equals 2 to the x, right? And it's shown over here and it's graphed. And it's exponential growth. We'd all agree? And they also have the line y equals x drawn in there, don't they? Okay. So first question is this function 1-to-1? Do you remember how to do that?
The horizontal line test.
Yeah. So is it 1-to-1?
Yes.
Yes. It passes the horizontal line test. Okay, that's easy enough. All right, so based on our answers from part A, what must be true about the inverse? Well, if the function's 1-to-1, then the inverse must be a what?
1-to-1 as well.
Maybe, but at the very least, it is a function, right? It would pass the vertical line test. Okay. So now in part C, they want us to create a table of values for the inverse. So the way they set it up is pretty easy, right? So the inverse is we just switch the inputs and outputs, right? So if you look up top here, that's our original function, right? Here's our inputs x and our outputs y, or f of x, right? They're interchangeable. And, you know, normally we'd switch x and y and solve for y, but they gave us a table of values, and all we have to do is switch the inputs and outputs. So let's go ahead and do that. So to start out here, still on the same page. So what will be our first value in the table for x, for the inverse? If we're switching them from the table above. Everybody see this here?
1/8.
So 1/8 will go here, and then what goes in the y?
-3.
-3, right? We're just switching them. So let's copy this over then, right? So then we'll have 1/4 will output a -2, and 1/2 will give an output of -1 for the inverse. 1 gives a 0, 2 gives a 1, 4, 2. And 8 outputs a 3 for the inverse of this function. Okay? So let's go ahead and plot those points there the best we can. Okay? And some of them we're just going to have to kind of estimate a little bit, right? So the first point there would be 1/8, comma, -3. So let's go on our graph. 1/8 is really close to 0 there, right? So, and then -3, 1, 2, 3, be down like here, wouldn't it? Roughly, you just have to estimate 1/8. And then 1/4 would be at -2. So 1/4 roughly, right? And then half would be at -1. And then 1, we're right at 0, okay? And we go over 2 and then up 1. So starting to look like a reflection here. And over 4, we go up 2. And then 5, 6, 7, 8, we go up 1, 2, 3. And let's see if we can get a smooth curve through here. Best I can. I missed a couple of points there. Right? So this would be f inverse of x. So that looks like a reflection of the line y equals x, right? Okay? So we know it is the inverse because it is a reflection. And by the way, what did I just tell you the inverse of an exponential function is? It was on the notes page. What do you think we just graphed there? What function? The what? What does that sound? So guys, if this original graph here was our exponential function,
we thought that logarithm, function.
So what we just graphed is the log function. Logarithmic, we can just say log, okay? As long as you know it's logarithmic, right? So that is the function of the logarithm, the inverse, that undoes the exponential function, all right? What does part D want us to do? So what would be the first step in finding an equation? Well, we know how to do that, right? What do we always do to find an equation of an inverse?
We swap the x and the y.
Switch x and y. Then what? Then solve for
inverse.
Y.
Solve for y.
Right? Okay? All right, so that's the first example. They didn't really call it a logarithmic function, but hopefully you're kind of catching on that that's what that is, because it's the inverse of exponential, and we just showed it was a reflection of y equals x, right? So down here they kind of do what I gave you on the notes page here, not quite as clearly, right? So they have here the log, y equals the log base b of x, right? Whatever number is in the b is the base of that function, right? Is the name we give is the inverse of this, right? It's the inverse of that guy, right? And now we still have b to the x. So notice the b is the base, x is the exponent, right? How it kind of lines up with the log base b of x, right? And so down here, they switched it the other way, right? They put the y here in the beginning. So if we have this thing down here, remember that tells us that b to the y, they went the other way that I did, right? Equals what?
Y equals.
B to the y power equals x, okay? So that's kind of what I told you on the notes page. That's what that logarithmic function means, okay? It's the same as b to the y being x as an exponential function, okay? All right, let's see what's on the next page. So let's work through these couple of examples here, get comfortable with it. So we're on the next page now, exercise 2. So evaluate the following logarithms, okay? If needed, write an equivalent exponential equation. So let's just go through this real quick. Let's just say each one of these equals x. We don't know, right? Because we want to know what the log, what's the base of this log? In A.
2.
2, and they want the log base 2 of 8. Well, this means, right, this statement here that they wrote means that 2 to some power x equals 8, right? That's what this means. 2 to the x equals 8. All right, so what is x then?
X equals 8.
No,
X 4.
not 4. Let's write 8 as base 2.
3.
8 is 2 to what power? Use your fingers.
3.
3. So what does x equal?
X equals 3.
X equals 3. See how we did that there?
Power.
Yeah. So x equals 3 in that sense. So the log base 2 of 8 is equal to 3. So let's look at the next one. Log base 4 of 16. Let's say it equals x, right? You want to know what that means. So that means 4 to some power x equals what?
Equals 16.
Okay, so 4 to some exponent x equals 16.
And
So what does x equal?
X has x equals 2.
Right, we know 4 squared would be 16, right? Yeah, we could write this with common bases though, couldn't we?
Yeah, reach.
Right, to get to what you just said, so x equals 2. Okay? Let's look at the next one. Log base 5 of 625. We want to know what that equals. I don't know. So as I wrote it there, what would be the equivalent exponential equation?
Five.
5 to the 5 to what power? Follow the arrows.
5 to x power
Equals
equals 625.
625. Right? So now we have to write 625 as a power of 5. Right? It is, in fact, a power of 5, which makes this nice and convenient. 625 would be 5
To the
to
fourth power.
4 power. Let's use our fingers. 5 times 5 is 25. Times 5 is 125. Times another 5 is 625, right? So it's 5 to the 4th power. So what does x equal?
X equals 4.
Yeah. Okay. Let's try the next one here. I'm going to have you guys try that. See if you get the idea. So write an equivalent exponential equation like I've been doing in the first 3, okay? And then get common bases and see what the log base 10 of 100,000 is. I'll give you a minute.
Equals
10x, 10 to the x power
10 to
equals
the x equals
100,000.
equals
So 10 to the x equals 10 to what power? How many zeros are there?
the fifth power, because that's 5 zeros.
Yep, so it's to the 5th power, right? So x equals 5. Okay? Let's try e down here. Let's evaluate the log base 6 of 1 over 36 equals x. So what's our exponential equation that's equivalent here? 6, what?
6x equals
6 to the x equals
6 to the x equals 136.
1 over
1 divided
36.
by 36.
All right. So you know 36 is a power of 6,
Which
right?
is
But it's at
common
the
base.
bottom, right? So 6 to the x would equal 6 to what power? Be careful here.
6 to the negative 2.
Right, negative 2, right? So x equals negative 2. Okay? Okay, you guys try this next one. Make that equal x, and then write an exponential function, and then figure out what x needs to be. I'll give you a second. Anybody get what f equals here? Log base 2 of 1/16?
Yes, x equals negative 4.
Negative 4, good. So this would mean 2, am I recording? Yeah. 2 to the x equals
X equals
1/16. Yep.
1 over 16. X, which is the common base, is
Yep.
2 to the negative 4.
There you go. Simple enough.
Let's see what's negative 2.
What's that? Oh,
Well,
sorry,
negative
not negative 2. That is not negative 2. Why would I have written such a thing? It's negative 4, isn't it? 2 times 4 is a, yep, negative 4. Sorry about that. Okay. Now the next one here, well, that's a square root of 5. But can we write the square root of 5 as an exponent?
Yes.
What would it be?
5 to 1/2.
Yeah, remember that? So we did 5 to the x equals 5 to the 1/2. And now it's pretty easy, right? What does x equal?
X equals 1/2.
1/2. All right. We got one more here. The 5th root of 9. So we can rewrite that exponentially, right? So it would be 3 to the x equals 9 to what power?
9 to the 5th
to the
1/5.
1/5 power, right? Well, we
And
don't have
find
common,
base,
so the
which is
common
3,
base would be 3.
which means the 3 to the
3 squared, but 2 times the 5th is just 2/5, right?
3 to the 2/5.
And so x
So x would
equals
So x would equal 2/5.
2/5. 2/5, okay? So if they have the, radical form, you want to rewrite it in exponential form, all right? Okay, let's move on to exercise 3. Before that, so it's critically important, right? Logarithms give exponents as their outputs, okay? So when you take the logarithm of some base and number, you end up getting the exponent, as you can see, right? All these values of x that we got, are they not what the exponent is supposed to be? They are, okay? All right, exercise 3. If we graph this function, the log base 2 of, notice how they group the x plus 8 in parentheses, plus 9. So the only thing you're taking the log of is the x plus 8. And then you're tacking on plus 9 at the end of that, right? If this was graphed, which would represent its y-intercept? Where do we find the y-intercept, kids? At x equals what?
X equals 0.
0. Well, let's figure this out. We're going to replace the x with 0, right? So we'd have y equals log base 2 of 0 plus 8 plus 9, right? So that would be y equals log base 2 of just 8, right? And out here we'll have plus 9. Okay, so the log base 2 of 8, we were doing that kind of work up top here, weren't we? So let's just take a look at this, put it over here. This log base 2 of 8. Rewrite that in exponential form, the log base 2 of 8. What would it be? 2 to the
2 to the
x equals, think about what we did up top.
3.
Not 3,
2.
8.
2.
8. 2 to the x equals 8. Oh, you said 3 like as the final answer. Okay. I was just looking for the. So yeah, right. So that means that 2 to the x equals 2 to the third, right? So x equals 3. Okay. So let's put that back down in here, right? We know that thing now equals 3, doesn't it? So just y equals 3 plus 9. Y equals 12. You get where that 3 came from down there? When we evaluated this guy right here, right? That became a 3. And so the coordinates of the y-intercept would be 0, 12. That's where it would cross the y-axis. Okay. Does anybody have any questions on exercise 3? Did I lose anybody there? Because I know there was some work off to the side there, which may have complicated it a bit. So just a reminder, if at any point, we do something that you don't understand, stop me and ask a question. You may have a question on example 3. It's kind of important to know. All right, let's go to example 4 then. Question is, between which two consecutive integers must the log base 3 of 40 lie? Consecutive means one right after the other, right? Well, let's see. What would be the equivalent exponential here? 3 is the base, so 3 what?
3
To the x, to some number, right?
Equals
Has to equal 40. Well, is there any way to write 40 as in 3 with common base?
no.
No. So they just want us to kind of estimate what that exponent has to be. Well, let's try some exponents for the x. What is 3 squared?
3 squared is 9.
9. What's 3 to the third power?
27,
27. What is 3 to the 4th power?
81,
81. 81. Hey, does our 40 lie in between these two?
yes.
Okay. So between what two values should x
3 and
be?
4,
Right, so 3 less than x less than 4. That makes sense? All right, so there's an actual way to solve that algebraically with the logarithms. But right now, you just kind of see that it's between 3 and 4. I didn't circle these answers. So there, what was the one up top? 12 up here, okay? Okay. Now your calculators, the one that you have online, so log's going to be written in different bases, right? Any base you want, because it has an equivalent exponential function in some base, okay? The most common logarithm base is log base 10, okay? Our whole number system is in base 10. So if you see something written like this here, you notice this is a log of x and there's no base given. You can always assume that the base is 10 if there's nothing written, okay? That's called a common log, right? So if no base is written, assume it's 10. If no base written, assume 10. Okay? So again, if you just see log of x, you say, well, what base is it? It's base 10. Okay? It's the most common one used out there. So just assume it's 10. Right? So let's look at some examples here. Exercise 5. Log of 100. What's the base of this, guys? What's the base in
base
8?
is 10.
Base is 10, right? So let's do it.
10 of x.
So 10 to the x
100.
power equals 100, right? We don't, I mean, come on.
And common base be 10 to
Right.
the second
I
power.
think we can just say x equals 2, right? In part B, log of 1 over 1,000. What's the base here? 10, right? So
10.
give me the exponential function.
That means 10 to x equals 1 over 1,000.
Right? So 10 to the x equals 10 to the
10 to the negative third.
-3, so x equals -3. Okay? And then part C, it's base 10 because it's not written there, right? So what's my exponential function? 10 to the x equals 10 to
10 to the
the
1/2.
1/2. So what does x equal? What does this evaluate as?
X equals 1/2.
So the log of the square root of 10 is 1/2. Does that make sense? Okay, does anybody have any questions on logarithms here? All right, let me stop this.